All right, so now let's talk a little piecewise function action. So we've talked before, I think we've talked before, that mathematicians are not creative. All right, so whatever it's called, that's typically what it is. And so for this instance, a piecewise function is just a little piece of a bunch of different functions put together. So for instance, like in example 1, I have f of x, and then you put these brackets on there, and you've got 4x. If negative 2 is less than or equal to x, which is less than or equal to 2. And I've got this negative 1/2 x plus 9 if 2 is less than x, which is less than or equal to 4. So what this is saying is I've got this line right here, and I'm taking this piece of that line. And here I've got this line right here, and I'm taking this piece of that line. So it's just taking a different piece of these lines. So the only time that 4x is valid, the y is equal to 4x is valid, is if my x values are between negative 2 and 2 inclusive. So if it's between negative 2 and 2 inclusive, then we're good to go. All right, so this is what we would like to see. First of all, in part A, I want to figure out what is the value of my function at negative 2. There is only one, right? The x's can't repeat. That's the concept of a function. So if I know that the x's can't repeat, the only place that x can be negative 2 is in this top function. There's no possible way for that to work for that bottom function. So I'm just going to plug this one into the top. So of this piecewise function, when f is negative 2, or f of negative 2, when my x value is negative 2, my y value is 8. Or pardon me, negative 8. So it's that coordinate point of negative 2, negative 8. So with a piecewise function, you can only have one piece. All right, let's try another one. Of this same one here, what if I wanted to know f of 2? Now that one looks a little tricky, right? Because I've got a 2 right here and a 2 right here. Is it going to go for my top function or my bottom function? The top one. Why? Because the top one is or equal to. So the top one is x is less than or equal to 2, so that works. Down here, this is up to the 2 but not inclusive, so it's still a function. You can only have one x value. You can't go in there and get all crazy with it. All right. What if I have, this is just going to be a rando part here. I'm just going to make a smiley face because that's awesome, right? So here's a smiley face part. What if I want to know f of 0? Where's that? Also in the top. Do you see that? Because 0 lands between negative 2 and 2. Because 0 is between negative 2 and 2, that's the piece that I'm looking at. So I have f of 0. So f of 0 here is 0. Now, we don't just always have to have that all the time. What if I have, like, example star, and I want to say f of 3? Yes, now we actually get to use that bottom one. So, oopsie daisy, my pen's getting a little wonky here. Let's try this again. It's negative 1/2 times 3 plus 9. So then you just work that out, right? F of 3, all of you people that struggle with fractions, get used to them. They don't go away. And they are awesome. All right, get your common denominator. So you have negative 3/2 plus 18/2, because that's 9. So negative 3 plus 18 will be 15/2, and you can just leave it in that, right? So look for where that piece is defined. And that's what we want to know. Where is that piece defined? Now the next thing that we're going to look at here, I do have some room on here, don't I? we're going to make a graph. I should have done graph paper. I think I'll do that for the next page. Put some graph paper on there because we are going to graph these. Actually, we'll save the graph for the next one so that you can see it. For this one, I'm just going to put the picture of the graph in there, and then we'll actually graph it for this next go around. And this way you still get to see it and you see how it works with that, but we're not going to take our time to graph it. We'll take our time to graph this next one and then go through the process to do that. Okay, so I just want to show you, look at these different points. So here's the point -2, -8. So on my graph, I have -2, -8, only one value. So this piece of my line is y is equal to 4x. From this starting spot to this ending spot. This little piece of my line right here is only from 2 to 4. So from 2 to 4 on the x, I start and I stop because it starts and stops there. The only reason why this is filled in is because 2 counts and these two match up. So then this, if I'm talking about the 4x line, is a solid dot. If I'm talking about this tiny little piece of this -1/2 x plus 9, I'm going to scoot this in. What this actually is a circle so that it doesn't count to the filled in dot. However, because my 4x line does count, that's already a value of my function, and then they just buddy up there. So that's what's happening. All right? Okay, so now let's actually graph one of these. If we have this next one, example 3. Oops, oh wait, I just told you I was going to do graph paper and I want to. So I want to add a graph paper. That way we can graph this easier here. All right, so we want this one. F of x is equal to x plus 1 when, or if, x is less than or equal to 2. 3 if 2 is less than x, which is less than or equal to 4, or if I have -2x plus 7, if x is greater than 4. All right? So that's what I kind of want to look at with all those different pieces to it. I do have one in your homework that you have to graph with a quadratic. Just use transformations to find the graph. All of the ones that you have to graph in my math lab are going to be multiple choice because there's no way to graph that in my math lab. So you're just going to use multiple choice, so use your deductive reasoning skills. However, on your test, I'm going to give you a piecewise function, but it'll only be linear that you have to graph. All right, so just heads up on that. Okay, so let's make our chart. Here, our grid. And let's graph these. Now, the first thing whenever I'm looking at a piecewise function, what I like to do is where are my stop-off points? So I have a stop-off point at +2. I'm not going to use this one. It's too thick. Let's maybe make that a little bit less here. So if my stop-off point here is +2, I'm going to put a dash line that I'm going to erase later, but that way I just know at 2. And I have another one at 4, right? Because this one goes to 4, and then I have greater than 4. So what I'm actually looking at here is this x plus 1, y is equal to x plus 1, goes up to the value of 2. Then, in between that, I have y is equal to 3 is the value that's happening in that section, that piece of it. And then finally, I have y is equal to -2x plus 7 is going to be to the right of that line. So do you see what's happening here? Just so I have these full graphs, but I'm only looking at the piece that goes in between there. So the piece that's going to go between these two are going to be these lines. So for the first one here, I'm going to have the line, I'm going to go back with green, y is equal to x plus 1. So you have a y-intercept of 0, 1, and a slope also of 1, so that's like 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. Notice that this counts, right? It lands on that 2. So I'm going to make that a, oopsie daisy, I'm going to make that a solid dot. So my piece through here is going to go up to there. So my y is equal to x plus 1 piece of this graph is going there. My y equals 3. So here at 3, I know that 2 is technically a circle. So, because this is 3, right? 1, 2, 3. So 2 is technically a circle, and then that's going to go all the way to 4, which is closed in. But because I already have that value closed in on green, I can keep that value closed in here, and I can go right up to that. All right. Now, let's see what's happening over here. Technically, I have my slope is negative 2 over 1. My y-intercept is 0, 7. So I'm going to take this up here to 7, 4, 5, 6, 7, and my slope is negative 2. Now, the only piece that this one is working with is going to be to the right of that line. So even though I start up here at 7, and I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. This is actually the first place that I'm working. So this is going to be an open circle, and I'm going to go down 2 over 1, and then I have my piece from there. So my graph is not continuous here, and I'm going to get rid of my blues because they're not technically part of my graph. They're just I like to call them cheater lines, so that it helps me see where my graph pieces are. And that is a piecewise function. All you're doing is just graphing the different pieces. That's literally it. Divide it up. Whatever you have over here as your division, divide that up, and then just graph whichever line goes in between those pieces, and then that's how you graph a piecewise function. Likewise on this one, let's say I wanted to determine what is f of, 3, right? So if I'm looking at f of 3, then I'm going to come down here on my graph, and I'm going to say, okay, right here at 3, I'm going to come right here. So what is the value of f of 3? Is 3. So you can still get that value, and you look at your parameters like what we did over here. 3 is in between 2 and 4, so I know it has to be part of this. If I can look at it on the graph, make that determination, you can also look at it whenever you divvy up your parameters over here. All right? Piecewise function, look at the pieces. That's the moral of that story. Just go through and look at all your different pieces, and you've got it. Cool.